ezinhle Ithala kanye neGo Digital SA Foundation. Thamelani izifundo ze-mathematics, i-accounting, isiZulu ulimi lwasekhaya, isiNgisi, i-FAL, i-physical science, i-geography, ezobuchwepheshe, i-computer applications technology kanye namaklasi e-learner wellness okungukuzilolonga ngokomqondo kanye nomzimba. Lezi zifundo zethulwa nsuku zonke kusukela ngoMsombuluko kuya ngoLwesihlanu kuqala ngehora lesi-4 kuya kwelesihlanu u-4 kuya ku-5 ntambama nangoMgqibelo kusukela ligamanxe ihora lesi-8 8:30 kuze kugamanxe ihora lokuqala emini 1:30. Zithameleni futhi lezi zifundo emsakazweni Ukhozi FM njalo ngoLwesine kusukela ngo-9 kuya ku-10 ebusuku. Ningangena ekhasini lethu lika-Facebook elithi Go Digital SA_movement noma kwi-YouTube uthi Go Digital SA Foundation. Siyethemba nizolijabulela lolu hlelo oluhlose ukunifundisa futhi lulekelele kulokho enikufunda ezikoleni zenu. Luthokozeleni ke lolu hlelo nimeme nabo bonke abanye abafundi bebanga le-12 grade 12 ukuze nabo bazuze kulo futhi nonke nicijeleke ukuphumelela kwizivivinyo zenu zokuphela konyaka.
Sanibonani bafundi. Mr. Mbayi lo khulumayo. Soba nani for i-physical sciences kuze kushaya uNovember. So sama prepare for your final exam. Soba nama sessions nje amaningana so that sikwazi ukucover yonke into ukuze nibe ready for i-final exam. Kwanamhlanje soqala nge-electrostatics. Electrostatics iqala grade 10, so it's irrelevant le content yonke grade 10 is still applicable. Right? Electrostatics just the study of static electricity. Masikhuluma nge-electrostatics sibona ama-charges, electric charges. Then so buyela grade 8, grade 9 sasikhuluma ngama-atoms. I-atom inama subparticles, inama subatomic particles, and sikhuluma ngama-electrons, protons, as well as ama-neutrons. Into sikhumbulayo ukuthi ama-protons are a positive charge and ama-electrons are a negative charge. So positive charges will be given to ma-protons. Mese siba nama negative charges, that will be ama electrons. Siyazi kahle ukuthi ama neutrons are uncharged, angana ama charges, right? So masikhuluma ngama protons and electrons, again with chemistry siyazi ukuthi an atom can only lose or gain electrons, not ama protons. So sobona ukuthi if une substance it is like an object, this object is made of atoms, and siyazi ukuthi a number of protons equals the number of electrons. So at the end uzobona ukuthi ama numbers, number of protons azolingana ama number of electrons. So the fact yokuthi ama protons are positively charged nama electrons are negatively charged, then ama numbers ayalingana, so it will give you what? A net charge of 0. So at the end, so tiguti a atom is electrically neutral, right? So any object will be what? Electrically neutral. Now masiti electrically neutral ingoba sinama number of protons alingana nama number of electrons. Here I'll just take an example, 5 particles or plus lava represent ama protons. So like an example, lana sina 5 protons, so that makes it a positively charged. But the much fagama electrons now our 5, so this one becomes what? A neutral object. Simply ngoba ama protons alingana nama electrons. Into siyazi yokuthi an object can only lose or gain ama electrons, right? Then this object here is neutral object just because numbers are equal. Number of protons equals the number of electrons. Now, in which case so to the object is charged. Now you can use different method of charging. The commonly used one is tribal charging, when you charge by friction, right? So the object in contact with another object can lose electrons, not the other way around. The only electrons can be lost by this object. Asitige, this object here has lost ama electrons out too. So remember that charges ama protons are still 5. Now puma ama electrons out 2, then sell ama electrons out 3. So yabona ukuthi ama charges are balanced, because you have positive 5 ama charges ama protons are 5, that is positive 5. Ama electrons out 3, then you have negative 3. Maubuga in net charge, it gives you what? Positive 2. But the first one, monoguti besin ama protons out 5, that makes positive 5. Ama electrons out 5, that makes a negative 5. The total gives us what? 0. In Gako state, this object is neutral, right? On this one, monoguti net charge or positive 2. So this object will be said to be positively charged, right? Then in case this object gains electrons, so you can have 1, 2, 3, 4, 5 positive charges, ama protons. Then by tribal charging, this object now gained, let's say, 2 more electrons. So in total, cinema electrons are 7. Right, so when you look at that, Zomonoguti, ama number of protons did not change, so sana 5. Number of electrons maningi manje, so sana 7, that makes negative 7. At the end, sinamani negative 2. So Zomonoguti, the overall charge, the object negative. So this object is negatively charged. So this one is positively charged. It's an object that is positively charged. And the other one, this one is negatively charged. Right, so singatin in terms of ama electrons, every time as kulumange ngama objects that are charged, so kuluma ngama electrons, because only electrons will determine whether the object is charged or uncharged, or positively charged or negatively charged. So kule ukala sotini that this object has a deficit of electrons. So aya shorter ama electrons as compared to ama protons. So that object is positively charged. While kule isbili status sotini, this object has an excess of electrons. So maningi ama electrons as compared to ama protons. Right? So we say it is negatively charged. Right? So in the first year, when you have 2 charged objects, right? Now we'll talk about 2 charged objects, right? 2 charged objects. That will be the first case. 2 charged objects, right? With 2 charged objects, so monuti kuzoba ne impact, right? Kuzoba ne impact between the 2 charged objects. Into fancy kumbule from grade 9, uguti ama like charges repel, and ama unlike charges attract, right? Like charges attract. Masity like charges kulumango positive, no positive, no negative, no negative. Those 2 are like charges. Mas kulumangama unlike charges kulumango positive, no negative. There will be attraction, right? If you have unlike charges, right? Now, if you have 2 charged object, means example again, lo singaba na ukuthi una 5 protons and then abehlambe na 3. So yambona ukuthi this object is positively charged ngoba ama electrons are in deficit, or you have more protons as compared to number of electrons. Then there is another object here, hlambe yona inama protons out 3 pel, then has hlambe 5 electrons. So this object is negatively charged. Simneme lo A, lo abe B. Right. So what will happen is that these two objects will have an impact on each other. Ngoba lo positively charged, lo negatively charged. And njengoba sishilo earlier on ukuthi unlike charges will attract. So masibuka ngala so bona ukuthi ama charges lawa positive charges are 5. Right? Ngala ama positive charges are 3. Right? Masibuka ama negative charges are 3 ngala, ama negative charges are 5 ngala. Right? So masihlanganisa konke sobona ukuthi ama positive charges are 8 and ama negative charges are 8 as well. Right? Now mabuti lama object are 2, they come into contact. Right? The net charge, these two objects, mabuti abahlanganisa ke the object 1 and object B, lo usana 5 protons, lo una 3 protons. Then in terms of electrons, still lo una 3, lo una 5 electrons. So zobonuguti, this one behaves as one object. It's like one object. So the total number of protons remains 8 and the total number of electrons remains also 8. Right? So that one will lead us to what we call a conservation of charge. Conservation of charge. Right. Kushoguti, a charge cannot be created or destroyed, but can only be transferred from one object to another. The conservation of charge, right? The net charge of an isolated system remains constant. The net charge of an isolated system remains constant. And so by the time you can now separate them. Must be separated, then you see how the charge will be distributed. What before saying alapo, as Coulomb charge, electric charge. But by electric charge on its own, it is a physical quantity. Electric charge. An electric charge is a physical quantity. Masfiti is a physical electrical charge. City is a physical quantity. Minor physical quantity, it means we need to represent it in a symbol yakona. The symbol for an electric charge, it's Q. Then in a unit 40, the unit is the coulombs. So an electric charge will be measured in coulombs, capital letter C. Right. One coulomb, it's a big charge. Ingako sebenza ama small unit ama coulombs. So singakhuluma ngani nge-conversion. Right. Zomono kusetshenziswa ama millicoulomb, noma ama microcoulomb, ama nanocoulomb, nama picocoulomb. Right. So I mean ama millicoulomb, microcoulomb, nanocoulomb, and picocoulomb. But zomono sometimes you have to convert. Ngoba kufanele mawenza hlambe i-calculation usebenzise ni ama coulombs. So inofanele yazi in terms of conversion. How do you convert a millicoulomb into coulombs? Let's say it's in a 1 millicoulomb. How do you convert 1 millicoulomb into coulomb? So zoti 1 times 10 to the power -3. Right? Coulomb. Gamayamas you divide by 1000. If you have 1 microcoulomb, how do you convert 1 microcoulomb into coulomb? Then that will be 1 times 10 to the power -6 coulomb. The nanocoulombs will also change that. 1 nanocoulomb will be 1 times 10 to the power -9 coulomb. The picocoulomb will be the same thing. It is 1 times 10 to the power -12. Into no yazi just webuke until no 3, no 6, no 9, no 12. Those are the unit SO7. The exponent final be negative ngoba lama unit lawa, they are smaller units as compared to a coulomb. Right. Now, the next thing, how do we find the charge of an object? Yakumbula ukuthi bengikhuluma ngama protons only, bengasho ukuthi what is the value of the charge? Right. So into fanele siyaziyo ngoba sifuna ukukhuluma ngani nge-charge quantization. Sesifuna ukuyicalculate ke manje. Charge quantization. Masikhuluma nge-charge quantization, sifuna ukubona i-quantity of the charge. i-charge quantization. I-charge quantization, it all depends on the number of electrons that have been lost or that have been gained. So the first thing, if I says it's in charge of an electron, right? A charge of an electron. A charge of an electron will give it a symbol QE, right? That will be negative 1,6 times 10 to the power negative 19 Coulomb. This is the charge of one electron. So we can talk about the charge of a proton. I want to call it QP here. It will be positive 1,6 times 10 to the power negative 19 Coulomb. Now, the charge of an electron is the smallest one, or negative, as compared to the charge of the protons, in terms of magnitude. So the next thing, for an object to be charged, it has to either gain or lose electrons. So the charge of an object depends on the number of electrons that have been gained or that have been lost. So in that way, we can say that if I want to find a charge object and I know the number of electrons, so we'll have the formula is what Q that represents the charge of the object, is what N is over number of electrons that have been lost or gained, so times QE. Right? The formula is 7 right? Q is equal to N times QE. I know sometimes we formula sheet to Q is equal to N times E. Nakon it's fine. We data sheet no formula sheet to N times E. Low E low represent what? The charge of an electron. Right. Now, if it's not given in that way, then the number of the charge sometimes as for somebody number of electrons. So the number of electrons is just what? The charge of an object divided by the charge of one electron. Right. So that is the charge quantization. And so the charge quantization simply says that an object has an electric charge that is an integer multiple of the elementary charge. The charge of an electron will be called what? The elementary charge. Elementary charge. Go over. The elementary charge, that is the charge that forms all the charges, right? That is the QE, right? Now, let's say, for example sake, as an example, right? Example 1, right? An object gains 6,000 electrons, right? Calculate the charge. Calculate the charge on the object. Calculate the charge of the object. Right. This object has gained what? 6,000 electrons. Those 6,000 represent an N. So now N is equal to 6,000 electrons. Right? 6,000 electrons. Now, what else do we know? QE, low CMAs, then they won't give you this quick statement. So low charge, this charge here, the charge of an electron. Data sheet, there is a table data sheet the charge of an electron, negative 1,6 times 10 to the power negative 19 coulombs. So it's Q. Q is equal to N times QE. So in our case here, we have 6,000 electrons times negative 1,6 times 10 to the power negative 19. So we can now have it, 7C calculator, we have 6,000 times, now the negative 1,6 times 10 to the power negative 19. Negative 19. The charge is negative 9,6 times 10 to the power negative 16 Coulomb. Right? That's how you calculate the charge. Right? So, lana simono kuti charge in negative. Go back to what this object has done what? Has gained. So we know that if it gains electron, the object will be negatively charged. Let's look at another example, right? Example 2. So an object loses, let's say 4,5 times 10 to the power 6 electrons. An object loses 4,5 times 6, 10 to the power 6 electrons. Let's calculate the charge on the object. Calculate the charge on the object. Again, into sensayo, we take down the data given. So 4,5 times 10 to the power 6 represent what? The number of electrons. So to n is equal to 4,5 times 10 to the power 6 electrons. Right? Message QE siamazi, that is negative 1,6 times 10 to the power negative 19. This is the charge of an electron. Now, when an object loses electrons, so the number of electrons that will be lost by the object will make what? A deficit electrons on that object. So ama protons alingana na lama electrons will be in excess. So when you have to calculate the charge, into just loses, that means the object will be positively charged. So if formula n is equal to n times QE. But at this point, the object will be positively charged, meaning ama protons as compared to ama electrons. Also to n 4,5 times 10 to the power 6 times. Now this time I'll say this is negative. Ngoba meaning ama protons. So you use what? The charge of a proton. So over plus times positive 1,6 times 10 to the power negative 19. Right? Then we get what? A positive, as a calculator, we'll have 4,5 times 10 to the power 6 times 1,6 times 10 to the power negative 19. And in that case, it's all about positive 7,2 times 10 to the power negative 13 coulombs. Right? It's always like that. Okay. Now, example 3. Example 3 is now when they give you the charge, calculate the number of electrons. The number of electrons. Number of electrons means you always have what? A positive number. You have to count, right? Like 1 electron, 2, 3, 4. So you can't have a negative number. Or you can't have what? A decimal. Half of an electron. So it has to be what? A full electron that is there. So in the lane, you answer a positive, and that will give you what? A whole number. Right? So example 3, an object has a charge of negative 36 microcoulomb. Right. Now, umbuzo 3.1 OT. Did the object lose or gain electrons? Let's say umbuzo 3.2 uzoti calculate the number of electrons. Calculate the number of electrons. Electrons that were gained or lost. Right. Now, the first question did the object lose or gain electrons? Right? Give a reason. Give a reason for your answer. Did the object lose or gain electron? Ito sibugayo the charge. Masibugi charge is more kuno negative sign. That negative sign simply says that this object has gained electrons. So the answer for 3.1, it gained what? Electrons. Give a reason. It is negative, right? You have what? The charge that is a negative. That is the reason you have, only because of that one. right? Then 3.2 to calculate the number of electrons, right? Into siyaziyo again sothi into sifuna number of electrons angisu n sifuna n, but into siyaziyo njalo le bani charge of the electron, that is negative 1,6 times 10 to the power negative 19 coulomb. Bese kuthiwa calculate the number of it. Then we don't know the number of electrons, but each charge, charge is negative 36 microcoulomb. Now, what do we notice here? Ukuthi abasebenzisanga ama-coulombs kodwa kusetshenziswe bani multiple small unit ka coulombs. Then siyazi ukuthi kwi-formula ngoba le charge of electron it is in coulomb, asikwazi ucalculate ama-coulombs nama-microcoulombs. We must all have in the same unit. So ingakho kufanele njalo si convert negative 36 microcoulomb to convert this into coulombs. Remember again sithe so t times 10 to the power negative 6. So kuzoba negative 36 times 10 to the power negative 6 coulombs. This is the value esosebenzisa kuma calculations, right? Then so t number of moles, number of electrons, N is equal to Q over QE. So in that case, we have the charge negative 36 times 10 to the power negative 6 over the charge of an electron negative 1,6 times 10 to the power negative 19. Calculator. So T negative 36 times 10 to the power negative 6 divided by negative 1,6 times 10 to the power negative 19. And loko kuskipela bani 2,25 times 10 to the power 14 electrons. Right. Ungatitishwa lo negative 2, this is not a decimal. Actually, we know 14 la. So if you have a 14, this is not a decimal. Ngoba uzothi say uthe asikwazi ukusebenzisa decimal. This is not a decimal ngoba kuno bani u10 to the power 14 ngoba masithi siyayibhala le number in full sothi u2 mesethiziti 1 2 3 4 5 6 7 8 9 10 11 12 13 14 ama zeros. This is the number. So you see that the whole number yona i-decimal ama electrons, and kufanele njalo uthole answer enjani a positive, right? So you make sure that you have a positive answer. The next example is sokhuluma ngani to calculate question 4. An object has a charge of positive 4,5 nanocoulomb, right? Mesokutiwa calculate the number of electrons lost. Lana ngisakuphindi lo mbuzo ngoba siyabona ke ngoba ku positive kusho ukuthi this object has lost ama electrons. So what do we do? Siyazi ukuthi n number of electrons nathi into sifunayo, then Q, that is the charge, siyamazi positive 4,5 nanocoulomb. Again siyabona ukuthi no khona nanocoulomb into sidinga izohambisana nani nale charge yama electrons ngoba yona it's negative 1,6 times 10 to the power negative 19 coulomb. So again we need to do what? The conversion. We need to convert this one. So we'll have positive 4,5 ngoba ku nano for 9, so T times 10 to the power negative 9 coulomb, right? 9 coulomb. Just remember that 9 nano and 9, so that oma micro, remember it's gonna be negative 6, right? Then so the formula is that n is equal to q over qe. Now this time around angithi just I charge I positive, so kuna ma protons amaningi as compared to ma electrons. So and sitting I answer a positive. So 4,5 times 10 to the power negative 9. Now on the denominator, even though sisebenzise le formula, siyazi ukuthi le charge is simply because of ama electrons that were lost. So our circle kule object. So sisebenzisani the charge that is responsive of this positive, and that will be ama protons. So sinama protons amaningi as compared to what? To ma electrons. So into final years when you use this formula here, usebenzisa i-charge ya lento eningi, like makunama electrons amaningi usebenzisa i-charge yama electrons, makunama protons amaningi then usebenzisa bani i-charge yama protons. So at this point soti positive asasebenzisa negative, positive 1,6 times 10 to the power negative 19. Right, the main purpose ukuthi sithole answer enjani a positive ngoba calculator ama number of electrons. Now 4,5 times 10 to the power negative 9 divided by 1,6 times 10 to the power negative 19. So sitola bani 2,8125 times 10 to the power 10. One number of electrons that are needed, that were lost by this particular object. Right. Ngiyathemba ukuthi sahambisana kahle. Then asikhulume ngama identical charges. Identical charges ngoba sithe ukuthi ama electrons, right? Ama electrons will never be lost, kodwa they will be transferred from one object to another. Identical charged objects. Identical charged object. Right. Now, if the charge is conserved and you have two objects, right? I have one object here. The object will be to A. So its charge A hlambe negative 3,2 nanocoulomb. Then object B that I say charge QB and positive 2 nanocoulomb. Now these two objects we can see with A has gained ama electrons ingako negative, B has lost ama electrons ingako positive. Now what will happen if A and B come in contact? Masekuhlanganisa A no B, right? You have object A and object B. Into enzekalayo lana ukuthi masekuhlanganiswa vele kuhlanganana nani nama charges. I-charge ka A it's negative 3,2. I-charge ka B to positive, right? Positive 2. So at the end, so thola bani net charge. Q net masekuhlangene A no B uzoba negative 3,2 plus 2, and then give us what? Negative 1,2, right? Nanocoulomb. So masohlanganisa A no B, they give you what? An overall charge. When the charge ka A hlanganisa ne charge ka B, just a plus, negative 3,2 plus 2 nanocoulomb. Right? Now, what happens now if we separate? If we separate A and B, right? Then kona separation. Konani is separation. Now, when they are still together, the net charge around them, right? Uzobabani negative 1,2 nanocoulomb. Into so ibona A unama electrons amaningi negative 3,2, B una positive 2. So when they come into contact, ama electrons will always try to fill in what the missing part. So ama electrons azosuka from A to B, right? But at that point, gonna reach what? A point where segiyalingana at the point where the next charge uzobabani negative 1,2. Right. Now when you separate them, and see net charge 1,2. When you separate, they share this charge equally. Ngoba state and lama object lawa are identical. Because they are identical, once you separate them, they give you what? An equal charge. So the charge that is new on A is equal to the charge the new charge on B, and then that will be what? The net charge divided by 2. So in that case, so tibani, a charge ga A is equal to the new charge B, and that will be negative 1,2 divided by 2, and that will be negative 0,6 nanocoulomb. So at the end, moguti I charge object A buyela ngala no B ula. The new charge ga A segubani, the new charge on A segu negative 0,6 nanocoulomb, and the new charge at B now so negative 0,6 nanocoulomb. Segiyalingana manje after a separation. Right. Then so the first charge charge A why no banu negative 3,2. The now A uno negative 0,6. So in that case, the charge on A has increased. Can the B why no positive 2, but now so no negative 0,6. The charge on B has done what? Has decreased. When an object gain an electron, net charge yakona decrease, and ama electrons are negatively charged. Right, so suga negative 3,2 siya negative 0,6. That is an increase. B suga positive 2 siya negative 0,6. That is a decrease. So into simbonoguti the charge on A increase while the charge on B decrease. Now umbuzo ngati, what is the charge that was transferred from A to B? Ngoba ukuthola lows negative 0,6 ungasebenzisa iformula elula kanje, uzothi what is the new charge? Uzothi the charge on A plus the charge on B divided by 2. So in this case, the charge on A, initial charge on A was negative 3,2 plus charge on B was 2, then divide by 2, logo kipela bani negative 0,6, right? Negative 0,6. I think in the calculation, right, 0,6 nanocoulomb, right? Lana 16 so convert as long as we have now at the end A no B kuzobe sekulingana no charge A yotoko negative 0,6, right? So initially the charge on A about negative 3,2 nanocoulomb. Then finally the new charge on A, so that initial or final, it's negative 0,6 nanocoulomb. So what is the difference? Right, so that calculator bani will change in the charge A. So Q final minus the Q initial. So that will be negative 0,6 minus negative 3,2. So it's going to be plus 3,2. So the difference is 2,6. Right, 2,6. That is the charge that was transferred. It means A has lost a charge of 2,6 nanocoulomb. Same thing will happen. The number is positive. A has lost ama electrons. B, Q on B initially 2 nanocoulomb, and the final charge on B, it was now negative 0,6 nanocoulomb. Masbuga difference. The difference is what Q final gap B minus Q initial gap B. The final negative 0,6 minus initial 2. So at the end sunobani negative 2,6 nanocoulomb. So zobonuguti, the charge that was lost by A is the same charge that was gained by B. Now you can now calculate what is the number of electrons that were transferred from A to B. Again, the formula says when you need to calculate the number of electrons, N is equal to Q over E. So that will be 2,6 times 10 to the power negative 9 lana kufanele wenze conversion ngoba ama nanocoulomb negative 9 divide by 1,6 times 10 to the power negative 19, right? Then we can calculate the number of electrons, right? All right, then masenza lokhu it means we need you just need to go through certain activities usebenzisa mhlambe a pass exam paper and so on, so that you can be able to do that, right? So as an activity to work on, right? Because object X, object Q, then X on a charge, let's say positive 3,5 nanocoulomb, charge Q in a charge of positive 2 nanocoulomb, right? X and Q, I would say P so that it won't confuse us. P, X and P are brought into contact. Then separated, right? So that is activity 1. Where the first question is what? Where electrons move from A to B or B to A, right? Into ngala, just look at the charge. The electrons will always move from the smaller charge to a bigger charge, because the smaller charge means it's more negative than the other one, even though low positive, but this one is small as compared to low 3,5. So it means electrons will move what? From P to Q. That the only thing the charge low positive, then you look at the magnitude. Low 2, this one is 3,5. So it means this one, or positive 2, is more negative compared to low positive 3,5. So ama electrons azosuka ku P aya kubani ku X, right? So that is how you need to do that. Mese umbuzo zoti calculate 1.2, calculate the number of electrons. Calculate the number of electrons transferred. Electrons that were transferred, right? So this is our activity. As a practice activity, right? I'm just guiding you, like on the first one saying upendule lombuzo, 1.2 saying yashoge, you need to calculate the number of electrons. Awusebenzisi lo 3,5, awumsebenzisi nalo 2. Into yazi ufanele ukuthi wazi ukuthi when X and P they come into contact, they'll give you what? A net charge. Uzosebenzisa kala le formula izoti Q is equal to Q1 plus Q2 over 2, utoli net charge. Then uzowenza a difference between 3,5 na leo charge uzoitola. Then that difference about the charge, yona uzosebenzisa na le formula izoti N is equal to Q over QE, right? So that is the practice exercise. So that was the first section under electrostatics, right? The next one, right? The next one will be on Coulomb's law. Coulomb's law. Coulomb's law, right? Now, nyakumbulu kuti site ama like charges attract and ama unlike charges will repel. So uzomono kuti if I have a charge, an object that is charged, an object A again, on an object B that is charged, lambele object in a charge got 600 microcoulomb, positive 600. Lo abe charge kabi ube lambe negative 450 microcoulomb. Now, into says ukuthi because this one is a positive charge, nalo negative charge, there will be an interaction. Ngoba ba unlike charges, there will be what? Attraction. So if there is an attraction, kusho ukuthi lo B, no A, B uzoyangala toward A, and A will be toward B. Now for this object to move that side, singabuyela futhi kuma Newton's laws, right? Newton's laws. The first law ikhuluma ngokuthi an object can only move if there is a force that is applied to that particular object. So this object here, ayikwazi ukumove if there is no force. Kusho ukuthi A exert a force on B, but at the same time B exert a force on A. Then isikhumbuzani Newton's third law. Niyakhumbula ukuthi Newton's third law says if object A exert a force on object B, then object B will exert an equal force in opposite direction to object A. So means that A exert a force on B. Now Coulomb's law calculated the magnitude of that particular force. Right? What is the magnitude of the force that A exerts on B? Into says the force is the same. The force that A exerts on B is the same force that B exerts on A. So in that case, so to F, it's calculated that F is equal to K times Q1 times Q2 over R squared. That is the formula that was developed by Coulomb. Right. So the magnitude of the force that exists, that A exerts on B, it will just be equal to what? To the product of the charges. So sebenza charge ka A and the charge ka B, then over the distance between the two objects. The distance between two objects. Lo K lo ngamnaki ngoba K is a Coulomb's constant. K is the Coulomb's constant. K is the Coulomb's constant. So in another word, into sibona yokuthi the force it depends with products Q1 no Q2. At the same time, this force depends on the square of the distance between the two charges. That's why Coulomb's law will be stated as the electrostatic force that an object or a charge exerts on the other one is directly proportional to the product of the charges and inversely proportional to the square of the distance between the two charges. That is Coulomb's law. Right. For today, guys, finally see my lab. Then next time, so Coulomb's law, and we finish up the electrostatics for what is required we exam. Right, siyabonga and siyathemba ukuthi nifundile. Thank you.
Siyathemba nifunde kahle nasithokozela isifundo sethu sanamhlanje. Enisethulelwe ngezidlokotho ezinhle Ithala libambisene neGo Digital SA Foundation. Thamelani ke futhi esilandelayo ngesikhathi sifanayo. Ningakhohlwa ukumema nabanye abafundi bebanga le-12 ukuze nabo basizakale kulolu hlelo. Uma ninemibuzo noma nifisa ukuxhumana nathi, ningasithinta ngokufaka imibuzo yenu kwinombolo yethu ye-WhatsApp ethi 068 151 1072. Mfundi, ungakhohlwa ukubhala isifundo obuza ngaso ngaphambi kokubhala umbuzo wakho. Angiyiphinde inamba yethu 068 151 1072. Siyabonga.